Hello and welcome to our webinar on how to leverage object storage to solve your data challenges. My name is Adrian Herrera. I am the VP of Marketing at Caringo. Before we start, a few housekeeping items. If you have any questions throughout the webinar, go ahead and write them in the question dialogue, and the presenter, Tony Barbagallo, will try to answer them throughout the webinar. If not, we'll have a short Q&A session after. And with that, Tony, why don't you introduce yourself and get everything going?
All right, thanks, Adrian. Yeah, my name is Tony Barbagallo. I'm the VP of Product here at Caringo. And we're going to give a high-level overview of object storage, its place in the enterprise storage landscape, and actually talk about a few use cases where we see object storage here at Caringo as very applicable to taking on the challenges of the enormous proliferation of unstructured data. So with that, I'll start, and I have the agenda slide here, which I just talked about. So just again a quick overview on the enterprise storage market, maybe a couple differences of object storage versus typical NAS and SAN, and then move on to those business issues and touch on some use cases. So very quickly, who is Caringo? We've been in business for over 10 years. Our founders actually developed some initial technology that was acquired by EMC and became the basis for the EMC Centera product. So we have our roots in content addressable storage. Caringo Swarm, our flagship product, actually has a number of compliance capabilities like worm and legal hold embedded in the product based on those content addressable storage roots. Given that we've been around so long, we have over 500 real-world deployments, some large, some small, and some in between. Cloud service providers like Telefonica and BT, Department of Defense, who uses us to store all of their medical images, and web service providers like Maps.com, Apps.com, and other just internal enterprises and general service providers, whether it be for active archiving or for thin provisioning primary storage off to object storage. All of those use cases are in play and growing with object storage. So let's just set the stage. It's no surprise really to anyone that the enterprise data landscape is changing. And depending on which analysts you speak with, there'll be anywhere from 7 to 40 zettabytes of data by the year 2020. And yes, that's zetta with a Z. And further, the prediction is that 80 to 90% of this data will be unstructured. By the way, a quick definition of unstructured is most data is unstructured. A photo is a piece of unstructured data, for example. A log file, customer information, all of that is unstructured data, in that it can be used and does not necessarily have to be stored in a file or folder system hierarchy. And with all of that unstructured data, there's an additional issue, and that's the expectations of users to be able to store everything now that they create. Not only end users, but also enterprises want to be able to access that information forever and from any device. We tend to refer to this as cloud conditioning, or the cloud age. And those who have grown up in this cloud world expect on-demand and instant access to that information. As an example, gone are the days of waiting for a specific day and time to catch up on your favorite TV show. Just go to Hulu or HBO On Demand and watch it now. Adding yet another layer of complexity is the unpredictable nature of access. Access is now going to come directly from applications over the web by potentially millions of users with unpredictable access patterns. Today, access is still coming through standard storage protocols, but as we'll see in a bit, that's really starting to change. And so this next slide is a comparison of what happens in an internet minute, and this is compiled by Fresh Infos. If you want a close look, just do a Google search for Fresh Infos, FRESHINFOS, internet minute. And these are arguably the fastest growing applications in the world. Some of them were pretty leading edge at the time for the kind of data they were storing, and both data that were stored by end users as well as enterprise data that they were storing about those end users. Most of them created a proprietary infrastructure, and that was out of necessity. There really wasn't any commercial-based infrastructure for this type of data storage and growth and search capability. So they're really experiencing, what we like to call web-scale growth, and need to ensure an exceptional user experience at the same time. So that means instant access to data, or their businesses will suffer and probably disappear just as fast as they appeared. Interesting example here. I don't know if anyone knew that Instagram and Pinterest were founded in 2010. Vine was founded in 2013. I mean, this is really just a testament to how quick this type of data has been getting created and growing, and this whole unpredictable nature of data growth. So it's also an example of you really don't know what apps will need to access data even a year from now. So it's really separating the data access from the data itself. Look at Instagram's growth in a year. 76% more photos uploaded per minute. And I'm sure that number is even higher today. And keep in mind that much of the information flowing through these networks is now enterprise data. So this not only the pictures that you or I store, or the tweets or the updates to our status, but it includes all of our demographic information that these organizations are storing: user behavior, log files, advertising tendencies, etc. So this is a great indication of how enterprise data and data access patterns are changing. So now let's take a look at the current storage technologies we have to store all this data. So here are the three, if you will, main network storage technologies. You have block. So in block storage, data is organized as an array of blocks. You carve out a portion of these blocks to form a volume that can be formatted as a local block device. On the file system side, the files-based storage is based on the file system, and that file system manages directories, files, and storing on disks through inodes and those blocks. Because of the use of inodes, there are finite limits to how many files can be stored, and most file systems have problems scaling beyond the petabyte range, as well as beyond the billions and billions of files range, even if they are very small files. And then lastly, there's object. So object storage is based on key value addressing. Store an object, get a key, just like a car valet. Give them your car, you get a ticket. Give them the ticket, you get your car back. Access for block storage is usually through a client on an operating system over fiber channel, iSCSI, ATA, over Ethernet, etc. Those fixed system attributes are stored with the block. So block storage is ideal for transactional or structured information like relational databases or running VMs, and that's optimized for performance or IOPS. File-based storage is usually accessed via standard protocols like NFS or SMB. Fixed file attributes like type, size, date created, date modified, they're all stored in the file system. So file storage is based on and is good for shared files and shared directories, either over a local area network or wide area network. For object storage, the client or access method is usually an application over HTTP. And system or custom information about the file is stored in metadata. So an object is ideal for shared, infrequently changing files and for scalable multiple site deployments. So now that we've established the network storage technology options, let's take a closer look at business issues that are are driven by this changing landscape of enterprise data. So the first business issue is really a paradigm shift, and the graph actually shows what we here at Caringo have seen over time at various organizations. When we first launched our storage software product back in 2006, IT budgets could still handle sort of the price, capacity, and performance, that whole mix offered by file-based and block-based storage devices like NAS and SAN. But over the last several years, we've seen a noticeable increase in interest in object storage in general. Data growth and limitations in traditional technologies were starting to stutter at the petabyte capacity range. And for many companies, growth is only increasing in momentum. And again, I'll point out that it's not necessarily just the growth in capacity, but growth in number of objects or files, even many, many small files for some of our customers. You add to this the effects of the cloud, with users expecting that always on, always accessible storage and access from new web-based applications. The early adopters in the market and those with rapidly growing data sets, it really saw the writing on the wall for this paradigm shift. And again, what worked for them in 2006 and even in 2013 really is not going to work too far forward into the future. Storage budgets really aren't increasing at the rate of data. This is a textbook indicator that you need to do something new altogether. And what many of our existing customers did is start looking at how those web scale companies that I mentioned in the previous slide and those services that they were offering, how were they storing their data? And that led a number of them to object storage and to our product, Caringo Swarm. So let's take a look at the second business issue. And the second business issue is really around cost and productivity. So if you look on this graph, on the left-hand side, you have capacity. At the bottom, you have price. And on the right-hand side, you have local or web-based access. So you can see where object storage fits in from a capacity, cost, and access perspective versus SAN and NAS. From a raw cost perspective, SAN is around, let's say, $2 to $3 per gig. NAS maybe around $1 per gig, and object can get to well under 30 cents per gigabyte of data. Most analysts will agree that the lion's share of growth is happening in unstructured data, and that most of this data needs to remain accessible and searchable to drive productivity and business agility. So this is a new opportunity for object storage within the data center. If you want reliable, scalable storage over a petabyte that's instantly searchable, then object storage is really the only practical way to get there. So now let's take a look at the next slide is around the notion of software defined and the effect overall of software defined. So all prices are decreasing because of the use of commodity hardware in the software defined landscape. In addition, the market for traditional NAS appliances is eroding because of software NAS options. So object storage is also chipping away at NAS use cases, as we'll show later. Because object storage is so adaptable, you can use commodity or standard hardware servers with higher performance characteristics now to meet a number of the traditional NAS workloads. Conversely, you can use lower performing and therefore more economical servers if you're just implementing sort of an active archive or a cold storage use case. So we saw in a previous graph, the overall opportunity to use object storage in the data center is increasing. And that's ultimately making your IT budget go a lot farther while increasing that business agility and overall productivity. So let's take a look at now the third business issue, which is risk. And if I start from a storage perspective, risk can come from many forms. But I've tried to list here the high-level reasons that we're seeing companies move away from traditional technologies, and even some software-defined storage solutions. So if I start sort of on the bottom left and work my way around, the first elements of risks are complexity and cost. Many traditional solutions, or even some new open source solutions, are very complex to deploy and are cost prohibitive due to the rate of data growth, either from a capacity standpoint, a configuration standpoint, or purely a human capital standpoint. The second elements of risk we're seeing are just lots of files, limited scale, and single points of failure. So as I mentioned before, many traditional NAS solutions start to have issues beyond a petabyte and can't scale really well over 2 petabytes in any one location. So many organizations that we're seeing and that we talk to are either approaching or exceeding those limits today. And then kind of the third major risk element is data silos, or locking data into a single location and limiting the ability for reuse and analysis of that data. So this is really a big issue in big data, life sciences, medical imaging use cases, where sharing information can literally be a matter of life or death. And I'll add one more last, but certainly not least, is the overall risk of data loss. As we'll see as we go over, again, some of the upcoming use cases, the complexity of file-based solutions at scale has actually led to lost data for some of our customers. And that's been driving also the switch to object storage. And that happens either through limitations in the ability to scale or through long rebuild times for RAID implementations, at which if data is lost during a RAID rebuild or there's another disk corruption, that actually can lead to data loss. So what are the general characteristics of software-defined storage? There's content addressable storage. I've heard object storage, scale out, enterprise cloud, public cloud, hyperscale, S3-like, S3 compatible, next generation NAS, NAS 2.0. All of these have some notion of software-defined storage, and the essential elements are starting with commodity or standard servers, abstracting the storage software from the underlying hardware, adding end-to-end management services and access, an ability to scale out the hardware, and all with built-in fault tolerance. You can see the quote from IDC, which says software-defined or object storage is here to stay. Such solutions are a core part of the scale-out solutions, leveraging distributed data storage. So that's a notion of software-defined storage. And I just want to bring in where we're kind of different from a technical standpoint. So the first is that with Swarm, Caringo Swarm is all-inclusive software. So when you're rapidly scaling, you need to be able to just plug in additional hardware and boot from bare metal, and that's what we do. You don't want to mess with installing operating systems, legacy file systems, RAID underlying for the hardware, patching or running complex scripts. And all storage nodes in Swarm perform all processes. So, beware of controller nodes and other specialized nodes. At the multi-petabyte level, these will become difficult to manage and size. So when all nodes do the same thing, all processes get faster as the cluster grows. Along the same lines, we believe that the metadata should be stored directly with the data. If it isn't, you create a single point of failure and limit the ability to continuously optimize. So with Swarm, that metadata is instantly searchable. We have an embedded search capability with our storage software, so no separate database or query mechanism is needed. You can search the entire storage cluster via programmatic API or with our web-based UI. And finally, we focused on ease of data protection. So in object storage, there are essentially two ways to protect data: replication, which is creating additional copies, and erasure coding, which splits the data into multiple segments, where you can lose a certain number of segments and still get your data back. Similar to a sort of a software version of RAID. So Swarm is unique, though, in that you can store replicated and erasure-coded objects all on the same nodes and seamlessly shift between one protection method and another if you so choose. We have a customer in Europe that streams video, and they'll do 100 replications of a new release of a movie so that they can optimize for access. And then after about 90 days, when the movie becomes less popular, they automatically change the protection policy from those 100 replications to erasure coding 10.4, and now they've got back about 90% of the storage space they were using for those initial replicated versions of the replicated copies of the movie. So in addition, so that's an interesting application, if you will, for the ability to be able to sort of shift as the life cycle of your data evolves. In addition, multiple access via different interfaces is important. So we offer S3 compatibility at the protocol layer, as well as seamless NFS and SMB access with our secondary product called FileFly. So the value here is being able to leverage and easily manage the infrastructure for a wide variety of use cases by selecting the interface and optimizing for specific workloads through the use of different commodity hardware. So for example, if you have an archiving use case, use a file system interface with dense storage on the back end. If you have a big data use case, you can use the Hadoop interface with higher performance servers and less dense storage, and all backed by Caringo Swarm object storage. So the best way to probably show this off is just to talk through a few use cases. So the first one I have here is a medical imaging use case via the Department of Defense. So they have multi-petabytes provisioned in object storage, and their goal was to consolidate the medical images for all of the armed forces. So there's field level governments, long-term investment protection. They need incredible durability of the data. There are hundreds of geographically distributed sites around the world. Some of those sites are connected via internet. Some are with separate clusters where, believe it or not, the disks are actually transported to a main storage cluster, and then just seamlessly absorbed into the object storage environment. So, and really their goal was to eliminate storage silos and enable value through this, if you will, a universal accessibility. So really, again, an example of a traditional storage environment looking for cloud-based storage optimized for accessibility, not necessarily though in a cloud like an AWS or an Azure or something like that. So all if you will, managed internally by the organization. Another one on the what I'll call is service delivery, cloud service delivery front. Healthcare performance management is our customer, Zermed, and while they don't have, they're not storing from a capacity standpoint that large of a petabyte configuration. They literally have billions of files, billions, and for them the issue was the backup windows. Billions of files need to be backed up. They're constantly getting added. They constantly added more files. Their backup windows were getting very onerous. So again, in an object storage environment where protection is inherent in the platform, there's no more backup windows because your storage is automatically backed up. It can be asynchronously sent to a disaster recovery site without any downtime to the primary cluster. So they solve the traditional file system corruption and performance issues at scale, and as well as making use of Hadoop and HDFS for with Caringo Swarm on the back end for a more efficient archive and disaster recovery platform. And then another interesting one is around big data. So one of our customers stores log files from Splunk, and then they used to move those data files off onto Isilon, and they were just finding that Isilon was reaching the limits of the speed and the capacity at which they needed to move those files and then re-access them. So the swap here was from Isilon onto Swarm, and really what they accomplished was they reduced their total cost of ownership, and again, with the bulletproof protection from a durability standpoint, they didn't have to worry about losing any data, and the metadata approach, enables them to write native analysis applications on that same log file data, so they can peruse the metadata for the log files and do custom applications on that data. And then the last one is around cloud services storage as a cloud service. So British Telecom, BT, actually provides a public cloud compute and storage cloud, just like Amazon and Microsoft Azure. They chose to offer as the back end Caringo Swarm. So the Caringo Swarm object storage is the back end infrastructure for the BT compute and cloud storage business. So what they do here is they're actually able to host sensitive data in the country of choice. This is very important for people in EMEA and the EMEA privacy laws, where they need to know where their data is being stored. Their solution allows you to pay just for the storage you use. So they have file sync, share, and backup applications that are all leveraging that lower cost unstructured storage. High SLAs depending on the service you choose, and it's really enterprise class end-to-end security, performance, and reliability. So those are just a few of the use cases that object storage addresses, and you can see, I think, from just a summary standpoint, we talked about the notion of endless capacity, accessible anywhere, and always available. And hopefully, I've showed you some good examples of how object storage really addresses these key issues as we move forward with this relentless growth of unstructured data. And with that, I'll see if there are any questions.
Thanks, Tony. So as mentioned, go ahead and type in your questions in the question dialog box. We'll give everyone a few minutes to ask questions. So we have one coming in, Tony. So how do you integrate object storage in your existing file environment? What are the options?
Sure. At least with Caringo Swarm, I alluded to a product called FileFly, and what FileFly is a Windows application. So it runs on a Windows server, and it natively integrates with NTFS. I'll talk about NetApp in a second, but for NTFS, it's a native integration, which means access via NFS or SMB, and because it's a native integration, there's a lot of solutions out there that have developed access as a gateway. And what that means is they're trying to sort of be all things to all people, but in doing that, they're having to recreate the file system hierarchy. And now, as you can imagine, when I just said that, that makes that Windows-based server or whatever they're running on a bottleneck. So you've got you may have a large pipe of users and home directories coming in on one side. You have a large pipe that's fully scalable of object storage on the back end, but then you've got this small little kink in that pipe of an application that's having to completely recreate a file system hierarchy. Because we've directly integrated into NTFS, we can make use of Windows clustering technologies and everything that Windows has brought to bear to make their file system as efficient as possible. That same application also works with NetApp file servers. So we've also tapped into the NetApp fPolicy API, and we are able to offer that same interface into the filer world from NetApp filers as well. So specifically, what we do with FileFly is your access to your files does not change, whether it's users' home directories or programmatic access. And we simply transparently migrate back and forth the data to and from those filers into Caringo Swarm. Effectively, what we're doing is giving you a notion of thin provisioning your file server. So it may look like to the end users that there could be a half a petabyte or a petabyte of data being stored on your file server, but behind the scenes, you've migrated that information and that data over to Swarm, and you may be able to get back a whole bunch of that primary storage, and that's really good for less frequently accessed data that you know isn't going to need to move back and forth very much. So that's and again, that also focusing on that less frequently accessed data is another way to lower any kind of bottleneck that might exist.
We have another question. Is it cheaper than AWS? So is it cheaper than Amazon Web Services?
Sure. Tough. It's a tough question to answer, and the reason for that is it really comes down to from a cost standpoint, the answer is yes. From a business standpoint, the real question is, do you have a data center in existence that you can leverage already? If so, then it absolutely is cheaper to move your data or to have your data on premise with cloud-based access than to store it off in a cloud service provider. Now, if you don't have a data center, you're just starting out, and you don't have the personnel to manage a data center, then that's where it may make sense to start your application with AWS. But it's interesting. I just read an article this morning where Dropbox had a bulk of their data, the bulk of our data. If anyone uses Dropbox out there, stored in AWS, they just brought it all back into their data center, and they're starting to create their own data centers because they've realized that that's fundamentally their bread and butter is providing efficient access mechanisms to the data that their users are storing in the cloud, and they feel like that is not something that should be left to a third party.
So, and how do you recommend organizations get started from an object storage perspective? How do you recommend they go upon researching the different solutions and just getting started with object storage in general?
Well, I think the easiest way is if there's an application you already have in mind, we can certainly provide our software to get started. We have now a content portal so that you can see how easy it is to upload and then check. For instance, maybe you have an S3 type application you want to build. We can show you compatibility there, and that all can be done online. If you want to bring the storage and test it out in-house, then we have a full VMware environment to get started with, and you can do some functional testing there, or you can set up a complete cluster. And the minimum we recommend is a 3-node cluster just for high availability and disaster recovery standpoint, and then you can just go up from there.
All right. It doesn't look like any more questions are coming in. We'll give everyone a few more seconds. Here's one. So how do you interact with NetApp? Can I use my NetApp as primary storage and leave 3-day snap on primary NetApp storage and move rest to object storage? How do I do that?
That's exactly what FileFly does. So if you do a search on NetApp fPolicy, and fPolicy is one word, it should be the very first thing that comes up other than the NetApp AdWords. It says what F policy is in NetApp. And that's what we've taken advantage of. So F policy, basically what happens is Firefly via this F policy server in NetApp tells NetApp so in your example, I would like to store all snapshots greater than 3 days. I would like to remove them from NetApp and just leave a stub there and put them in Swarm. And that's what the F policy server API allows us to do, and that's what we've taken advantage of.
And
hopefully that answered your question. So I was going to say, hopefully that answered your question. It may be a little bit more involved based on what I'm reading here, but that's the general premise of how we work with NetApp.
And for Firefly in general, let's say this person wants to test Firefly out. How do they do that in their environment? How do they get started?
Again, all of that can run in a VM. So that software we can certainly provide to you very easily. And from there, it self-configures. So you just need to have some information about your NetApp filer, and you can see it in action.
What would you say the average time to set up the solution up, or just to set Firefly up is?
Setting up the Firefly solution in a Windows environment is fairly straightforward. I think the only issue in a NetApp environment is you actually have to be the one who has access to that NetApp server administrative access. But it's not that difficult to set up this interaction of the F policy server with NetApp.
All right, we'll give a few more seconds to see if any more questions come in. It doesn't look like any are coming in. All right, do you have anything you want to add, Tony?
No, just thank everybody for your time. It was a pleasure presenting this very exciting subject, and look forward to doing it again.
Likewise. You see Tony's email there, tony.barbagallo@caringo.com. You can also go to our website, caringo.com. We have a lot of great resources in the resources section. A lot of great webcasts on Bright Talk, webinars on Bright Talk that you can view at your own leisure. If you have general questions, feel free to send them at info@caringo.com. Again, Tony, thank you for your time. And
thank you all.
This concludes our webinar. Thank you, everyone, for joining us.